This project starts with one question: how to face the urgent needs of an existing city like Zagreb. To answer it, I decided not to focus on the city itself, but on the highway that connects it to Vienna. This project faces the problem of global warming on its maximum scale. This is, how to effectively reduce the concentration of carbon dioxide in the atmosphere. Let me start this story by jumping into the future. Let's look at the material trace that this process of carbon capture has imprinted on the landscape. It's the year 2190. The process of carbon capture ended 10 years ago. Now, the only thing that remains is the trace of the infrastructures we used to capture such carbon: craters, mountains, and constructions made of ash bricks. In this reality, the ashes are the main residue of the carbon capture process. We use them to build walls, factories, and vaults. Such constructions still emerge throughout the territory. The injection wells have already been sealed, and only empty shells remain. Let's go back to the present time. The levels of CO2 in the atmosphere reached 415 ppm in the year 2021, the highest levels in the last 10 million years. The last reports from the IPCC conclude that we are not cutting down emissions fast enough to avoid the effects of climate change. To do so, it is imperative to start building a massive negative emission system that captures carbon continuously for the next 150 years. The current arrangement of the territory is based on the use of fossil fuels, and this forces us to look for solutions of the same order. Carbon capture technologies already exist, but not on a global scale. It remains to be seen how this global transformation of infrastructure will manifest in the landscape. This project wants to tell that story. This project proposes a carbon capture system informed by state-of-the-art climate studies and existing technologies. It is based on the current territorial structure, and it simply reverses it, repurposing the infrastructure so it eliminates carbon instead of producing it. The BECCS system is based on the capture of CO2 through perennial crops, that is, the combustion of biomass. This process ends with the injection of CO2 deep underground, removing it permanently from the atmosphere. This process is replicated in other 30 areas of territorial transformation around the world. We'll focus on area number 5, which encompasses the cities of Zagreb, Graz, and Vienna. The CO2 capture capacity of the area is determined by the surface for biomass crops that this area can hold. To effectively capture and transport the CO2 to all injection points, the local industry and existing natural gas pipeline network are used, which are scattered across the territory. The highway acts as the spinal cord which links together all the elements of the project. As we travel along this highway, we notice several areas in the landscape, which we've called weird spaces. Weird spaces appear in areas of greater intensity, where several elements within the negative emission system converge. Around these hotspots, edges are drawn with a strong formal condition, taking advantage of the highway as a showcase of the territory, making visible the infrastructure enclosed within them. Let's now focus on 2 of the 7 spaces. The first one contains a thermal power plant and a CO2 pressure station. The main gas pipeline passes through the second one, which contains a biomass processing plant and CO2 injection facilities. In this reality, the Malak power station is transformed into a carbon capture power station by introducing a post-combustion CO2 absorption module. The compressed gas is transported through buried pipelines to the injection points. We're now reaching the final phase of the capture process. For gas to crystallize safely on the ground, the CO2 taken from the gas pipeline is dissolved in water, and transported by elevated pipelines to the injection domes. The buried pipelines are marked with beacons as a signaling system. As the pipeline passes through the weir space, the signaling system is distorted. The invisible trace of the pipeline becomes a mobile sculpture that sways in the wind. The topography gives spatial sense to the infrastructure. The terrain absorbs the shapes of the injection facilities and the weir space, leaving a permanent footprint of the long carbon capture process. This space is a place of strangeness, where the infrastructure becomes arterial. The CO2 capture systems become visible and evident, as physics take on special importance in these places. The soil moves from the craters to the mounds that outline the edge of the weir space. The slopes never exceed the friction angle of the ground. Rainwater is collected to feed the injection process. Drainage water is stored along a section of the highway of 1 kilometer in length, also using the water drained naturally from the topography. Due to gravity, the water falls down into the open reservoirs. The low evaporation rate in the area allows the reservoirs to be built as bowls excavated into the ground. As months go by, water rises. Puddles emerge around the deposits, which are covered with a draining pavement made of ash tiles that serves as an overflow. The elevated CO2 pipelines also act as lining lines. During the combustion process, 3% of the biomass has been transformed into fly ash. This residue has become the vernacular material of the post-carbon era. All bricks and paving pieces used in this project were built from this recycled material. Following the curve of the weir space, the ash brick factory appears. This factory is also built with ashes, the same material it produces. The same for the injection domes. A robotic arm builds them automatically using the recycled ashes. We have reached the end of this presentation. In this project, we introduce you to a new paradigm, the repurposing of existing infrastructure into a global carbon capture system, destined to sustainably remove CO2 from the atmosphere across a 150-year time span, restoring the carbon levels of the atmosphere to healthy levels. What remains of this long process is the footprint that has been left on the landscape, as a 200-year trace of fossil fuel dependence.